Okay, we want to talk about row times column, dot product, and angle between vectors. And we're going to do this in the context of projecting one vector on another. So let's just start with vector v, 3, 1, and w, 2, negative 1. If we represent v as a row and w as a column, so we represent v as the row of 3, 1, the row 3, 1, then we're going to say that v dot w equals the row 3, 1 times the column 2, negative 1. And of course that product is 3 times 2 plus 1 times negative 1. And that adds up to 5. So v dot w is 5. Now, we can prove, and I'm not going to prove it, although it's pretty much a high school or pre-calculus level proof, by the law of cosines. And you can try to prove this if you want, because if you have the trigonometry background, it's not that difficult to prove. Look up a proof. Beg me to prove it, and maybe I will. It's an easy enough proof. We just don't want to get too far from the idea of the linear algebra. I'm just saying, if we can justify by the law of cosines that v dot w equals the magnitude of v times the magnitude of w times the cosine of theta, where theta is the angle between v and w. Well, that means, in this case, for example, we can easily find the angle between these two vectors. Now we can see where these vectors are. We can sketch them. Maybe you already have, because that's kind of be an almost automatic thing to do when you see two vectors in R2, at least. You'd want to sketch them, but v is going to be out about here. And w would be 2 here and negative 1 here, so it would be something like this. Okay, what's the angle between these vectors? Well, if w was down here at 1, negative 3, it would have the negative reciprocal slope of v, and it would be perpendicular to v. But 1, negative 3 is way down here, so this angle is quite a bit less than 90 degrees. Okay. So we could calculate it. Okay, we can calculate the magnitude of v and the magnitude of w by the Pythagorean theorem. For these vectors, so I'll just say here, theta would be the inverse cosine of what we get when we divide both sides by magnitude of v times magnitude of w, and that would be v dot w divided by magnitude of v times magnitude of w. We just calculated magnitude, or we just calculated v dot w, so we'd have the inverse cosine of v dot w is 5 magnitude of v is the square root of 3 squared plus 1 squared. Okay, by the Pythagorean theorem. What's the length of this thing? It's over 3 up 1. So you have legs 3 and 1. 3 squared and 1 squared is 10. So the magnitude of this thing is the square root of 10. That's the magnitude of v, and similarly, the magnitude of w is the square root of 5. Okay, well, at this point, you can just put that into your calculator, but that's no fun. You should always think through the calculation before you start pressing buttons, at least for quite a long time until you're really secure with what is really happening. Plug it into the calculator at this stage and you lose track of all the arithmetic. If you're in a big hurry, yeah. But just don't be in a big hurry all that often. Okay, well, the square root of 50 is just a little over the square root of 49, which is 7. So it's going to be the inverse cosine approximately (5/7). And 5/7 is what? It's 0.701. If this is just a little bigger than 7, as it will be because 50 is a little bigger than 49, turns out to just be 0.7. Okay? Now, the cosine of 45 degrees is the square root of 2 divided by 2, which is 0.707. And don't be like me. Don't leave out important things. Yeah, that's 0.7, 5 over 7. Now remember, we're doing the inverse cosine like I didn't. So there's inverse cosine of 0.7. That's pretty darn close to 45 degrees. Or pi over 4. And of course, you write down an angle without degrees or anything on it. It means it's in radians. Okay, so 45 degrees or pi over 4 meaning pi over 4 radians. Radian being the default measure of angle. Okay, so there we've got it. Now, where does that leave us? Well, if the vectors that we have here were 3, 1, and 2, -1, so we'd have the v and the w, and we would then know theta. Then we could calculate the magnitude of the projection and go just a little bit further. Okay, well, I'm going to do that, but I'm going to do it in a separate video. What we want to understand right now is this dot product and the relationship between the dot product, the magnitudes of the vectors that you're doing the dot product of, and the angle between the vectors. So right there is the connection.